Okay, so 19.3 is called equations in quadratic form. So what we're going to be doing in these notes is we're going to be doing a lot of U substitution. So remember we talked about that a little bit when we first started quadratic equations, more than a month ago, I feel like. And we did one problem with that U substitution. Now we're going to look at some more problems with the U substitution, and a good chunk of the test that's coming up is going to have the U substitution in it. Okay, so that's why we're doing entire notes on it. Okay, so we're looking at using U substitution and then how to solve these quadratic equations by reducing them first. So concept one is the most important part. So in concept one, solving equations using substitution, this is just another name of saying that U substitution. We're going to be given an equation that has parentheses in here that look similar. So for example, in this problem, we have that 2x squared minus 5. And notice how it's written twice. We have it written once with the exponent of 2, and we have it written again with an exponent of 1. Okay? These values here we're going to be using for the U substitution. So it says, looking at the example equation above, we see that the equation has a pattern that is called quadratic in form, meaning it looks like we could turn it into a quadratic equation. We can use substitution and assume that U is equal to that 2x squared minus 5, so that parenthesis that's repeating, to give us the quadratic form U squared minus 16U plus 39 equals 0. Notice how instead of 2x squared minus 5, they put a U. Okay? Instead of 2x squared minus 5, they put a U. So now we have U squared minus 16U plus 39, which is a lot easier to factor than the equation above. So what we're going to be doing in these examples. Okay. So looking at the example that we had above, we said that these values here are going to be our U values. So I'm going to say let U equal 2x squared minus 5. So anywhere I see that 2x squared minus 5, I'm plugging in a U. So now I have U squared minus 16U plus 39 equals 0. So anywhere I saw that 2x squared minus 5, I plugged in a U. Okay. Now this is something that I am able to solve by using either factoring or the quadratic formula. Okay. So I'm going to first attempt to factor this, and I'm going to factor it using that AC method. So I have A times C, which is 39, because there's not a value in front of that U squared. And our B value is what number? Negative 16. So I need two numbers that multiply to 39, but add to negative 16. 13 and 3. And would they both be positive, both be negative? Both negative. So negative 13 times negative 3. If I add those together, I get negative 16. So that means I'm going to be using these terms, plugging them back in so I can use factor by grouping. So U squared minus 13U minus 3U plus 39 is equal to 0. So we're doing the same type of factoring here, and just instead of our variable x, we now have our variable u. So if I was to factor out a GCF from the first one, what could I factor out? U. A u. So if I factor out a u, I'm left with u minus 13. And I want my second parenthesis to match. So what am I factoring out? A negative 3. So I'm left with u minus 13. Okay. So that means I have my two factors, u minus 13 and u minus 3 equals 0. What's my next step to solve for u? Set them both equal to 0. So u minus 13 equals 0, u minus 3 equals 0. So when I do that, I'm going to add the 13 over and I get u is equal to 13. And then add the 3 over and I get u is equal to 3. Okay. However, this cannot be my final answer because what variable was my original equation in?
X.
It was an x. So instead of saying u is equal to 13, we know that u is 2x squared minus 5. So I'm going to write 2x squared minus 5 equals 13. And I'm going to solve that one for x. And then I'm going to do the same with the u equals 3. So starting with the 13, I'm going to add that 5 over. And I get 2x squared equals 18. Divide by 2. And I get x squared is equal to 9. And then how do I get x by itself? Square root. And when I take the square root, am I going to have one answer or two answers? Two answers. One positive and one negative. So I have x is equal to plus or minus the square root of 9, which is plus or minus 3. Okay, so that's my first answer. Now I'm going to take that 2x squared minus 5 and set it equal to what number? 3, because that was the other answer I got for u. So I'm going to add 5 to both sides, and I get 2x squared equals 8. Divide by 2, and I get x squared is equal to 4. And so once I take the square root of 4, am I going to have one or two answers? 2. I'm going to have this x is equal to plus or minus the square root of 4, which is plus or minus 2. So that means I have my answers of negative 3, positive 3, negative 2, positive 2. Okay. So these are my answers. And you could leave it like that, or you could write it as, because I think on Alex they would have you do negative 3, positive 3, negative 2, positive 2 in those curly brackets. These are both correct answers. That would be accepted on the test, and the curly brackets is just probably what the Alex software prefers. So again, this is called u substitution. We're taking an equation that looks like it could be quadratic, and we know that because it has two repeating parts. The 2x squared minus 5 repeats twice. We use that and set it equal to u, solve for a normal quadratic, and then plug in our values we get at the end to get our answers.
What was this called?
U substitution. And there's 5 questions like this on the test. So looking at number 2, what do we see that repeats twice? Good, that 3t squared minus 10. So that tells us that is going to be our what value? Our u. So u is equal to 3t squared minus 10. So that means everywhere we see 3t squared minus 10, we're going to put a u. So this is u squared plus 5u minus 14 equals 0. The reason we do this because this part here is a lot easier to factor than the above one. Okay. So now we factor this in terms of u. And then we can plug it in and find our answer for t. Okay. So using that AC method, AC is equal to what? Negative 14, and our B value is 5. So what are two numbers that multiply to negative 14 but add to 5? Negative 2 and 7. Perfect. Negative 2 times 7. If we add that together, we get positive 5. So I'm going to use those values to expand my answer, expand my equation. So u squared minus 2u plus 7u minus 14 equals 0. So after the AC method, I do my factor by grouping. And what GCF can I take out of the first one? Good, just a u. So I'm left with u minus 2. And what could I take out of the second one? A 7, because I want them to match. So u minus 2. So that means I have u minus 2 times u plus 7 equals 0. What's my next step? Good, set them equal to 0. So u minus 2 equals 0 and u plus 7 equals 0. For the first one, I just add 2 over and I get u is equal to 2. And then for the second one, I subtract 7, so I get u is equal to negative 7. Are these my answers?
No.
No, because u is 3t squared minus 10. So I'm going to have 3t squared minus 10 equals 2, the first answer that I got, and I'm going to solve. So add 10, and I get 3t squared equals 12. Divide by 3, and I get t squared equals 4. And when I take the square root of both sides, I'm going to get how many answers? Positive or negative. So t is equal to plus or minus 2. That's my first answer. Now I'm setting 3t squared minus 10 equal to what number? Negative 7, because that's the other value that I got. Add 10 to both sides, and I get 3t squared equals 3. Divide both sides by 3, and I get t squared equals 1. Which means when I take the square root of both sides, I'm going to have two answers, and those answers are going to be what? T equals?
Plus or minus 1.
Plus or minus 1. So for these ones, it's just one extra step. We already know how to factor with the AC method. We know how to factor by grouping. Now, once we find our answers, we're just plugging them back into whatever we let u equal to. Okay. Any questions?
On these ones, considering that there's so many solutions, usually 4 total, are we ever going to have to plug those back in to do our checks?
You only would need to plug it back in if you have a fraction where there's a variable on the denominator.
Gotcha.
Because we don't want that to be 0. But since these are not, there's no fractions and there's no variables in any fractions, you're good. We mainly do that when you see the rational equations because they are fractions. Okay. Okay. For no reason, I'm just going to star this one. Hint, hint. This one's important. So notice here, it looks like at first sight, we don't see anything that is repeating. Okay. Sometimes use substitution is not as obvious, and we're going to have to write this in terms of something that is being squared, and something that's being raised to the first power. So just like the ones up here, notice in the original problem we had something being squared, so this being squared, and then that same thing being raised to that first power. That's what we're going to have to do here. Okay. Typically when we see these type of problems, you're looking at the b value. So you're looking at this part right here, that b value. So the part after the b value. And that value is p to the 1/3. That's what we're going to let our u be equal to. So u is equal to p to the 1/3. Because if we need to plug in a u squared is just going to be that u value of p to the 1/3 squared. And when we have an exponent raised to another exponent, what do we do to those two exponents? Multiply. So what's 2 times 1/3? Keep it as a fraction. 2/3. So that means u squared is p to the 2/3. Do we see that in our problem? Yep, right here. This is the same as this. So when I'm plugging everything in, I'm now plugging in a u for the p to the 1/3, and I'm plugging in u squared for p to the 2/3. So this becomes u squared minus 2u equals 8. Okay. For these ones, I had to create my u and my u squared because it wasn't as obvious as the first two that we did. Now, before we start factoring this, what do we notice about this equation that we got?
It's not set to 0.
It's not set to 0, so we're going to subtract 8 over, and we have u squared minus 2u minus 8 equals 0. Now we have our a, b, and c value that we could factor using our AC method. So in this case, a times c is what number? -8, and our b value is -2. So two numbers that multiply to -8 but add to -2. -2 and 4. Perfect. Well, almost. -2 and 4 would give us a +2. 2 -4. 2 times -4. When we add those, we would get a -2. So those are our numbers we're plugging back in to expand our equation. So we have u squared plus 2u minus 4u minus 8 equals 0. After we do the AC method, we always do factor by grouping. Always factor by grouping. Next. So looking at the first parenthesis, what can we take out? A u, and we're left with u plus 2. And if we want our parentheses to match, what would we take out? A -4, because we want to be left with that u plus 2. So that means we have u plus 2 and u minus 4 is equal to 0. What's my next step? Set each to 0. U plus 2 equals 0. U minus 4 equals 0. And then I solve each one separately. So for the first one, I'm going to subtract 2, and I get u equals -2. And for the next one, I'm going to add 4 over, and I get u is equal to +4. Am I done? No. So I'm going to be plugging these in where u is, because remember we had two equations. We had a u equals and a u squared equals, but our answers are in u. So this is going to be p to the 1/3 is equal to -2. How are we going to get rid of that 1/3 that's in the exponents? Because we just want p.
Set it to the 3rd power.
Good. Raise both of these to the 3rd power. because remember, if we have a power to a power, we multiply, and what's 1/3 times 3? Just 1, and that's what we want. So we're raising both to the third power. So that means I have P is equal to -2 cubed, which is -8. Okay, notice in this one we only got the one answer. Okay. And then do the same thing. P to the 1/3 is equal to 4. I'm going to raise both sides to what power? 3, because I want to get rid of that 1/3. So I get P is equal to, is it 64? Yep, 64. Okay. And then these are my two answers. P equals 8 and P equals 64. Again, I do not need to plug them back in because in my original problem, there are no fractions where the denominator contains a variable. Okay.
Say that one more time.
I'll write it. I'll write it so you have it. So we don't need to plug in and check since there is not any fractions where the denominator contains a variable. So you would be looking for like a fraction that would be like 1/x. Since that variable is in the denominator, you would have to check to make sure it would not make the denominator 0. X cannot be 0. Good, remember this is all recorded so you can go back and rewatch as many times as you need. Okay, so number 3 is important. Okay, number 4. So number 4 is very similar to number 3. Here we do not have anything that looks obvious, that looks like, okay, something's repeating, that's going to be our u value. Since we don't see anything that's that obvious, what do we do with that second term? Make that u. So that means u is equal to y to the 1/3. Don't include the constant number in front. So in this case, there's a -1 there. We don't include that. We just include that variable and whatever is attached to that variable, the exponent attached to that variable. So now that we have u, we need to find u squared. And we just do that by squaring y to the 1/3. So that gives us what? Y to the 1/3 squared. Multiply those exponents. 1/3 times 2 is 2/3. Okay. So that means we have our u and we have our u squared. Okay. So I'm going to be plugging in those values. So now I have everything in terms of u instead of y. So I have u squared minus u equals 12. But before I can factor this, where does the 12 need to go? The other side. So I have u squared minus u minus 12 equals 0. Now I can move on to my AC method. What is A times C? -12, and what's my B value? -1. So two numbers that multiply to -12 but add to -1.
-4 and 3.
Perfect. -4 times 3. When I add that, will give me -1. So I'm going to go ahead and expand that so I can do factor by grouping. So u squared minus 4u plus 3u minus 12 equals 0. From the first parentheses, I can take a u, and I'm left with u minus 4. And from the second parentheses, I can take a 3. So again, I'm left with u minus 4. So I have u minus 4 times u plus 3 equals 0. Set them separately equal to 0. I get u minus 4 equals 0 and u plus 3 equals 0. And I solve each separately. So for the first one, I add 4 over, I get u equals 4. And the next one, I subtract 3 over, and I get u is equal to -3. Okay, is this my answer? No, what am I going to be doing with those u values that I found? Plug it into that u equals y to the 1/3. Okay, so I have y to the 1/3 is equal to my first one I got, which was 4. What am I going to do to both sides to get rid of that 1/3? Perfect, raised to the 3rd. So that means I get y is equal to 64. And then I have y to the 1/3 is equal to, what do we get? -3. Again, what am I raising both sides to? The power of 3, because 1/3 times 3 is 1, and we wanted that to cancel. So then I have y is equal to -27. Yeah, just make sure you plug that into your calculator. Any questions so far? Okay. Okay, here we have x minus the square root of x minus 12 equals 0. So we have a radical in here, that square root of x. And we want to go ahead and turn that radical into an exponent so it's easier to deal with. So the square root of x can be written as x to what power?
Oh, 1/2.
So people who said square, that was close, but since it's the square root, we do the power of 1/2. Anytime you see this radical here, your exponent's going to be a fraction. Let me write that off to the side. Radical means your exponent will be a fraction. And whatever index you see, that's the denominator of your fraction. So index equals denominator of fraction. So in this case, since we don't see an index number, we assume it's what? 2. So there's technically an index of 2 here. So that means if I rewrite this, this is x minus x to the 1/2 minus 12 equals 0. Okay. Which means, what is my u value? X to the 1/2. Remember, it's always that second term. U is equal to x to the 1/2. So u squared is going to be x to the 1/2 squared. And that's going to give me what?
X.
Just x, because 1/2 times 2 is 1. So I just get x. Okay? And I see an x up in my problem. Okay, because I see that this x right here is my u squared, and this square root of x right here is my u. So plugging that back in, I have u squared minus u minus 12 equals 0. Again, we do use substitution because this is a lot easier to factor than our original problem. So using the AC method, what is A times C? Negative 12, and what is B? So what are two numbers that multiply to negative 12 but add to negative 1?
Negative 4 and 3.
Negative 4 and 3. So we have u squared minus 4u plus 3u minus 12 equals 0. Now we do factor by grouping. And what's the first thing we can take out? A u. So we're left with u minus 4. And then what? A 3. And we're left with u minus 4. So we have u minus 4 times u plus 3 equals 0. What's next? Set equal to 0. U minus 4 equals 0. U plus 3 equals 0. Which means we get u is equal to 4 and u is equal to negative 3. Same u's we got in the last problem. But in this problem, what did we say u was? X to the 1/2. So I'm going to take x to the 1/2 and set it equal to the first answer I got, which is 4. And then I have x to the 1/2 set to the second answer that I got, which is negative 3. Okay. So what are we going to do to both sides to get rid of that 1/2? Square it. I'm just going to do this one first. So when I square the x to the 1/2, I get x. So x is equal to 4 squared, which is 16. So that's my first answer. For the second part, we need to remember that this x to the 1/2 is the same as the square root of x. Can we take the square root of a negative number? No, so that means this x to the 1/2 equals negative 3 means it does not exist. This does not exist because we can't have a square root ever equal a negative number. That's just not possible. Okay. So that means my only answer here is what? X equals 16. So keep that in mind if you have any of the exponents that have a, an even denominator. So 2, 4, 6, 8, any of those even numbers, we cannot have it equal to a negative answer. If denominator is even, can't equal to negative number, so it does not exist. Okay. So this would be the only time you really would have to quote unquote check, okay? Because you're not really plugging anything to check, you're just making sure, looking back at prior knowledge, that we cannot take the square root of a negative number without it being imaginary, okay? And in these type of problems where we're doing u substitution, there may be cases where they ask for the imaginary number part, but they will ask you, okay? This one is all in terms of real numbers. Okay. So go ahead and try this one on your own, because this one is almost exactly what we did in 5. Okay, so you're first identifying your u, then identifying your u squared, factor, and then plug in your u value to get your final answers. Okay, I'm going to go ahead and start going through it. So for number 6, you should have labeled your u as the square root of z, which this is the same as saying z to the 1/2. So that means your u squared is z to the 1/2 squared, which is z. Once you have identified your u and your u squared, you plug those in. So I have u squared minus u minus 2 equals 0. Again, we do this because the quadratic that we got in terms of u is a lot easier than the quadratic we have in terms of z. So we're going to use the AC method, which is -2 for AC and B is -1. So two numbers that multiply to -2 but add to -1 would be -2 and +1. Then you should have used this to expand. So u squared minus 2u plus u minus 2 equals 0. Do factor by grouping. And in the first one, we could take out a u, and we're left with u minus 2. And notice how the next parenthesis already is u minus 2. So that means we technically don't want to take out anything that's going to change our problem. So we're going to take out a 1, u minus 2. So if we take out a 1, it does nothing. You can divide everything by 1 and it stays the same. So we're left with u minus 2 and u plus 1 is equal to 0. Meaning you should have u minus 2 equals 0 and u plus 1 equals 0. giving us the values of u equals 2 and u equals -1. Okay, so that was the first part. Once we find our u values, we plug them back into whatever we set u equal to in the beginning. So in the beginning, we said u is equal to z to the 1/2. U is equal to z to the 1/2. Oops, I should not write it like that. Z to the 1/2 is equal to 2, and z to the 1/2 is equal to -1. So zooming in over here, what are we going to be raising z to the 1/2 to in order to cancel out that 1/2? 2. So we're squaring both sides. Okay. So when we do that, we're left with z equals 2 squared, which is 4. But for this one, we have to remember that z to the 1/2 is the same as the square root of z. The square root of anything cannot equal a negative number. So that means this part of the answer does not exist. So we only have one answer, which is z equals 4. This could also be something where, okay, I got that u equals -1. Let me plug in that -1 into that z value up there. I have a square root of a negative number. Does not exist. Okay. So you should have got just z equals 4. Any questions on concept 1? On concept 2, we're going to start off doing the same thing, but then some of the problems are going to get a little bit more complicated, so there's going to be a little bit more steps in there. There's just 2 of those. So looking at number 7, we're going to do the same exact thing we've been doing. So again, this looks like we don't have 2 things repeating. So since it looks like we don't have 2 things repeating, what is my u value?
X squared.
Good, it's good. It's always that variable after b. So at u is equal to x squared. So that means u squared is equal to x squared squared, which is x to the 4th, because a power raised to a power means we multiply. X squared squared is x to the 4th power. So now we plug everything in. We have 4u squared plus 7u minus 2 equals 0. Okay. In order to factor this, we do the AC method. And in this case, a times c is what? -8, because it's 4 times -2, which is -8. And our b value is 7. So what are 2 numbers that multiply to -8 but add to 7? Any ideas? Good, 8, -1. So 8 times -1. If you add that together, we get 7. So expanding my equation, I get 4u squared plus 8u minus u minus 2 equals 0. Do my factor by grouping. And what can I take out of the first parenthesis?
4u.
A 4u. And I'm left with u plus 2. And if I want to end with a u plus 2 again, what do I need to take out? a negative 1. So u plus 2. So that means I have u plus 2 times 4u minus 1 equals 0. What's my next step?
Set each one to 0.
Set each one equal to 0. On the first one, all I'm doing is subtracting 2 over, so I get u is equal to negative 2. And in the next one, I'm going to have to add 1, so I get 4u equals 1, and then divide by 4, and I get u equals 1/4. What am I going to do with those u values? I'm going to set them equal to what? X squared, because u is equal to x squared. So I'm going to do x squared equals negative 2. And then I'm going to do x squared equals 1/4. Okay. How do I get rid of an x squared? What am I have to do to both sides? Take the square root, and remember when I do this, I'm going to end up with 1 or 2 answers. 2. So square root of both sides on all my problems. So that means I am going to have x is equal to plus or minus the square root of negative 2. Notice how my answer has that square root of a negative number. This is when you would put this in imaginary numbers. Okay. We know that the square root of 2 is not a perfect square, but what could we do with that negative that's inside the square root?
Move it outside with the I.
Move it outside with an I. So this is the same as saying plus or minus I square roots of 2. So there's 2 answers there, that plus or minus. For the other side, when we take the square root, we're left with x is equal to plus or minus the square root of 1/4. What does the properties of radicals tell us we can do? Good. Take the square root of each. This is equal to plus or minus the square root of 1 over the square root of 4. And this can reduce to plus or minus, what's the square root of 1? 1. And what's the square root of 4? 2. So this is plus or minus 1/2. So we have 4 answers here. I'm fine with you leaving the plus and minus there as the answers, or I'm also fine with you doing this. Okay, negative I square roots of 2, positive I square roots of 2, negative 1/2, positive 1/2. This is also a correct way to write the answer. Just know on the test, if you forget this plus and minus, you're going to be marked off points because that's telling me you only have 2 answers. That plus or minus indicates 4 answers. So it's very important, that plus or minus, if you're going to leave it in that format. Okay. Okay, go ahead and take a moment and set up number 8. So I just want you to identify what your u value is and identify what your u squared value is and write that equation. I'll give you about 30 seconds to do that. Remember, we're just setting up our equation, we're not solving. So what did you guys get for u? X squared. So what did you get for u squared? So u is x squared, so it's u squared.
X.
Remember, it's x squared squared, which is x to the fourth. Okay, so that means you should have got the equation 9u squared plus 35u minus 4 equals 0. Three of the 5 questions on the test is just asking you to set it up, okay, not to solve. So it's just setting up. Only 2 questions are going to have you solve the whole thing. Okay, so now we're doing the AC method. So A times C in this case is what? Negative 36, because 9 times negative 4 is negative 36, and our B value is 35. So what are 2 numbers that multiply to negative 36 but add to 35? Good, 36 and negative 1, right? Because we want that negative 36, and then when we add that, we get a 35. So expanding, I have 9u squared plus 36u minus 4 equals 0. Now we're going to do factor by grouping. What can we take out of the first parenthesis? Any guesses? What are we taking out of the first one? 9u, good. So we're left with u plus 4. And we want that second parenthesis to also be u plus 4. So what should we take out? A negative 1, because we want to get rid of those negatives in front of the u and the 4. So that means I have 9u minus 1 equals 0. Oh, I skipped a step. U plus 4 times 9u minus 1 equals 0. And then I set them separately equal to 0. So u plus 4 equals 0 means u is going to be negative 4. And 9u minus 1 equals 0. I have an extra step here, so add 1, and I get 9u equals 1. Divide by 9, and I get u is equal to 1/9. But in the beginning, we said u was what? X squared. So that I'm going to do x squared equals negative 4, and x squared is equal to 1/9. And to get rid of a square, I do what to both sides? The square root. So I'm going to take the square root of both sides, and when I take the square root, I'm going to end up with how many answers? 1 or 2? 2. So I have x is equal to plus or minus the square root of negative 4. Can I simplify that?
Yes.
So what's going to happen with that square root of a negative? It's going to come out and become what? An I, and then can we take the square root of 4? So it's going to be, good, so x is equal to plus or minus 2i, because the square root of 4 is 2, square root of a negative, I. So that's our first 2 answers. So in the next one, we have x is equal to plus or minus the square root of 1/9. Property of radicals say we do what? Both. So x is equal to plus or minus the square root of 1 or over the square root of 9. So that means x is equal to plus or minus 1/3. So that means we have 4 answers here. We have positive 2i, negative 2i, positive 1/3, negative 1/3. 4 answers. Any questions on 7 or 8? So this is kind of still playing into concept 1, because we didn't do really anything different, and we labeled our u and u squared just the same. Now let's look at problems like number 9. Oops. Here, it's not obvious at first to see what is our u and what is our u squared. Because let's say we do the same concept and we use this as our u. If we were to square this, it wouldn't get anything close to this value. So for these ones, we're going to first treat this like it is a rational equation. And remember, rational equations mean that we need to get a fraction equal to another fraction. Okay? So we're going to treat this like rational equations. So we need a fraction equal to another fraction. So in order to do this, the first side, that left side, we need to combine those two fractions. And we need to do that by getting a common denominator. So we have one denominator as y plus 2, and the other denominator as y minus 1. So what would be the common denominator? Good, we would have to multiply them together because we couldn't simply just add a number to one of them. Because remember, when we are getting common denominators, we're always multiplying the opposite fraction to match up. So we're going to say that our common denominator is y plus 2 times y minus 1. So that means that first fraction is missing what? Y minus 1. So I'm going to multiply the top and bottom by y minus 1. What is that second fraction missing? Y plus 2. So top and bottom, I'm multiplying by y plus 2. This is my first step. So I have 3y times y minus 1 over y plus 2 y minus 1 minus 2 times y plus 2 over y plus 2 y minus 1 is equal to 1. Okay. Now my left side have a common denominator, so I can combine the numerators. Before I combine the numerators, I am going to go ahead and distribute those numbers outside the parenthesis. Okay. So I have 3y squared minus 3y. Minus 3y. And then on this one, I have 2y plus 4. Okay. This second part is being subtracted, so I'm going to have to keep it in parentheses. And this whole thing is now over y plus 2, y minus 1. Okay. Still going back to simplify the numerator, I'm going to distribute that negative in. It's going to change the signs. And I have 3y squared minus 3y minus 2y plus 4. Okay. All over common denominator.
Minus 4.
Minus 4, thanks. Okay. Now I'm just combining like terms. So I have 3y squared, that's by itself. Negative 3y and negative 2y gives me a negative 5y, and then that minus 4. So I have 3y squared minus 5y minus 4 over y plus 2 times y minus 1 is equal to, I want it equal to a fraction. So how do I turn 1 into a fraction? 1 over 1. Once I have a fraction equal to a fraction, do you guys remember what I do? Cross multiply. And since they're both being multiplied by 1, it's not going to change. It's just going to get rid of these fractions. So now I have 3y squared minus 5y minus 4 is equal to y plus 2 times y minus 1. Okay. What would be my next step? I have a y squared in my problem, so that tells us it's what type of function? Quadratic. And a quadratic function in standard form has to be equal to what? 0. So before I start moving everything over to the left side, what can I do to this first? Foil it. So I need to foil it out, and then I'm going to have it equal to 0 by moving everything over. So I have 3y squared minus 5y minus 4, just rewrote that left side, is equal to y squared negative y plus 2y minus 2. That's what we get when we FOIL everything out. So now I'm taking this entire side and I am moving it over. Which means when I move it over, the opposite signs are going. So it's going to be a minus y squared, a plus y, a minus 2y, and a plus 2. So I have 3y squared minus 5y minus 4 minus y squared plus y minus 2y plus 2 equals 0. Now that I have it all equal to 0, what should I be doing to the left side now? Combining like terms. So I have a 3y squared and a negative y squared, a negative 5y, a positive y, and a negative 2y, and a negative 4 and a positive 2. So I'm going to combine all those. So I have 2y squared minus 6y minus 2 equals 0. Okay. Okay. Before I start to factor this, does this have a GCF I can take out?
Yes.
A 2, I can take out a 2, and I'm left with y squared minus 3y minus 1 equals 0. So now I'm only paying attention to this middle part. So I'm going to factor with my AC method. So in this case, A times C is -1, and our B is -3. Are there any terms that's going to multiply to -1 but add to -3? No, so this means it's not factorable. But in the previous notes, we said if something was not factorable, we used the quadratic equation. Remember, those are the notes that I've posted for last class, and we'll go over some of those examples at the end. So not factorable. If something is not factorable, then your next thought should be, I need to use the quadratic formula. Quadratic formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, our a value is 1, our b value is -3, and our c value is -1. So I'm going to plug all those in. So x is equal to -b. Our b value is -3, so it's already negative. So a negative times a negative is a positive. So I have 3 plus or minus the square root of b squared, so -3 squared, minus 4 times a, which is 1, times c, which is -1, all over 2 times a, which is 2 times 1. So now we go through and we simplify this. Negative 3 squared is what? 9. Negative 4 times 1 times negative 1 is positive 4. What's 9 plus 4? 13. And then 2 times 1 is 2. So I have x is equal to 3 plus or minus the square root of 13 over 2. Is the square root of 13 a perfect square? No, so that means we cannot simplify this, and this is going to be our answer. So remember, from here we have two answers. We have 3 plus the square root of 13 over 2 and 3 minus the square root of 13 over 2. And I'm going to go ahead and move this so you can see that bar. Okay. So notice in this problem here, we did not have to use u substitution at all. We just used all our knowledge of other things, okay? So typically when you see a problem like this, they are not going to say use u substitution. They're going to say solve this rational equation. And you're going to solve it exactly like this using everything you learned for rational equations. And then last one, number 10. Similar to number 9. So we need a fraction equal to another fraction. So in this case, what's going to be our common denominator? Remember, if we don't know, we always assume it's the two denominators being multiplied together. So that means our common denominator is going to be 2t minus 1 times t plus 4. Okay? We always just multiply those denominators together. So knowing that's going to be our common denominator, what is the first fraction missing? T plus 4. So t plus 4. T plus 4, top and bottom, we're going to multiply that by it. What about the second fraction? 2t minus 1 times 2t minus 1. So we're going to go ahead and do that first so we can combine these two fractions into one. So I have t times t plus 4 over 2t minus 1 times t plus 4 minus 1 times 2t minus 1 over our common denominator of 2t minus 1 t plus 4. And that is all equal to 1. Okay. Now that we have a common denominator, what are we doing to the numerators? What are we going to do to the numerators now that we have a common denominator? Okay, we're going to combine them. So I have first distributing in that t. I have t squared plus 4t minus, and then distributing in that 1, 2t minus 1. All over our common denominator. So 2t minus 1, t plus 4 is equal to 1. Okay. Before I set my fraction equal to another fraction, I'm going to combine my numerators, so any like terms I have. So first I have to distribute that negative, and I get t squared plus 4t minus 2t plus 1 all over our common denominator. And then our last part here is I need to combine the like terms of 4t and negative 2t to give me a positive 2t. So t squared plus 2t plus 1 over 2t minus 1 t plus 4 is equal to 1. but I want my 1 to be a fraction, so I would write 1 over 1. So this is that first step. I'm just getting my two fractions that were on the left side to have a common denominator so I can have one fraction. Okay, I only want one fraction. Once I have a fraction equal to a fraction, what do? Cross multiply. So I have t squared plus 2t plus 1 times 1, so it doesn't change anything. And then 2t minus 1 times t plus 4 times 1, which again doesn't do anything. So now I have no more fractions. I have a quadratic equal to another quadratic. So I need to have this equal to 0. And in order to do this, I'm going to have to do what to the right side first? Foil it. Good. So I want it to look like that left side before I subtract it all over. So I have t squared plus 2t plus 1 is equal to, once I FOIL this, 2t squared plus 8t minus t minus 4. So I'm moving this whole thing over to the left side. So I have t squared plus 2t plus 1 minus 2t squared minus 8t plus t plus 4. Remember, when I move it to the other side, the signs just change. Because I'm subtracting the 2t squared, I'm subtracting the 8t, and I'm adding the t, and I'm adding the 4. So now I should be looking for like terms. So I'm going to go ahead and highlight all my like terms. And then I'm going to combine them. So I start off with my t squared. So I have t squared minus 2t squared. So that's a negative t squared. Bless you. And then I have 2t minus 8t. So that's negative 6t plus t, negative 5t. And then 1 plus 4, 5. Okay, so this is me combining all my like terms. And before I try to factor, what can I take out of everything? What GCF could I take out? Because I don't like that negative being there for my a value. A negative 1. So I have negative 1, so I have t squared plus 5t minus 5 equals 0. So I'm only looking at this inside part, and I'm going to do my AC method. So A times C is equal to what? Negative 5, and my B value is 5. Okay? I need to find two numbers that multiply to negative 5 but add to positive 5. Is that possible? Remember, the only factors of 5 are 1 and 5. So would either of those ever add to 5? No. So that means this is not factorable. And when something is not factorable, we use the quadratic formula. Remember, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So looking at our problem, our a value is 1, our b value is 5, and our c value is negative 5. So I'm just going to be plugging those into my problem. So I have x is equal to negative b. B is a positive 5, so I'm going to write negative 5 plus or minus the square root of b squared. So 5 squared, okay, minus 4 times a, which is 1, times c, which is negative 5, all over 2 times a, which is 2 times 1. So I'm plugging in my A, B, and C values from my quadratic equation into the quadratic formula, and now I'm going to simplify. So 5 squared is what? 25. And what's negative 4 times 1 times negative 5? Positive 20. So 25 plus 20 is 45, and then 2 times 1 is 2. Is 45 a perfect square? No, it's not a perfect square. But can 45, well, let me write this next step. X equals negative 5 plus or minus square root of 45 over 2. I'm just rewriting what we had up there. So 45 is not a perfect square. Is it something that we could reduce using the prime factor tree? Yes, so what prime number goes into 45? 3 goes in how many times? 15. And then what goes into 15? 3 and 5. And they're both prime numbers? And we're circling a pair of the 3s. Where's the 3 going to go? And where's the 5 going to go? Inside. So this is x is equal to negative 5 plus or minus, sorry, I want it in black. X is equal to negative 5 plus or minus 3 square roots of 5 over 2. Okay. Can we simplify negative 5, 3, and 2? No, so that means this is our answer right here. So this tells us we have two answers. We have negative 5 plus 3 square roots of 5 divided by 2, and negative 5 minus 3 times the square root of 5 divided by 2. So again, this is something that we did not have to use the u substitution on, since it was set up like a rational function. Fractions in there, that tells you it's a rational function where our variable is in the denominator. So you just use the concept of rational equations. Okay. Like I said on the test, I'm not going to just give you a problem. I'm going to tell you what to do with the problem. So I'm going to say solve the rational equation. So that tells you to go to your notes on rational equations and then solve it that way. Or I'm going to say solve by u substitution. That should tell you to go to these notes and solve by u substitution.